Hello everyone, welcome to section working with stream and lambda expression. Topic perform decomposition and reduction including grouping and partitioning on sequential and parallel streams. Please watch my video till the end. If you like my video, give thumbs up and click the bell icon to subscribe to my channel for the latest update. Advanced stream pipeline concept. You will see in this video the relationship between streams and underlying data, chaining optionals, and grouping collectors. To explain linking streams to underlying data, it is important to know about lazy evolution. Lazy evolution means delay execution until necessary. We create the stream object, but stream pipeline runs before the terminal operation. It won't run when we create the stream. Let's see that. I have created a project in IntelliJ Advanced Stream and created a class linking with a main method. I am going to create a list of string and add two strings. Now I am going to create a stream through the list and add additional string in the list. So if I call the count method, how many elements will be in the stream? Although I have created a stream, the stream won't run until terminal operation. It will count 3 elements. Okay. Next is chaining optionals. As of now, you have seen that chaining operation in the stream pipeline have a lot of advantages. The same thing in the optional class, method returns optional and we can call another optional method. I have created a class named chaining optional. With the main method. Suppose that you are given an optional integer and asked to print the value, but only if it is a 3-digit number. So 3-digit, let's do in the old fashion. So I have created a method. In this method, it says that if any value is present, then it gets the value and convert this value into string. And if this string length is equal to 3, it will print the string. Okay, so here the value is 4, it won't print anything. If I put here 1 2 3, it will definitely print. Okay, right? What would if I put what would if I put empty? It won't gonna print anything. Okay, as I have done in the traditional way, let's do the same thing in Java 8. Let's rename this method as Java 7, and this is Java 8 optional dot off 4. Right? So how I am going to do this one? Optional dot map. What the map does, it will convert the to string and then check that if the length of element is equal to 3. If it is and value is present, then print. So same thing if you do 1 2 3 here. And you are going to run it. Yes, it has given 1 2 3, same as the Java 7, but you can see that it is very readable as compared to the old traditional way. So let's create an optional string and I am going to call it optional, and then what I'm going to do, I'm going to call a map method and string into integer. So map function is for transformation, and let's call it result. So you can see that maps dot optional return optional string, and map also returns the optional. So there is a chaining. All right, and if you want to see the result, if you just do the result, it will give option 3, but if you want to get the value, you can use the get. All right, so which is 3. All right, so now you can see that the chaining is also possible in the optional. Let's do one more example. If I do optional dot map, and in this example I use a helper method, and that helper method has all the logic and which returns an optional. How can I get the value? So for instance, the class name is chaining optional, and there's a method calculator. All right, so right now we do not have a method. Let's create a calculator method. and this method returns optional integer. Okay, so optional integer is returned from this one, and it goes inside the another optional. See, and make it result 1. How are you going to get the value from this one? If you do result 1 dot get, so it will gives optional integer, and then you again need to call the get. So two gets, get and then get, to get the value. So let's write down a body. So it's return optional dot off s dot length. Okay, so now we get the 3. So it's a lot of digging inside, and if you don't want to do that one, there is another way. We can use flat map. What it does, it extract out all the values, put them in one collection, and then return it. See, so it is now only optional integer instead of optional of optional integer. So result 2, and if I say s out result 2 dot get. Right, so it has pretty much has become like this. So that's what I have shown you, that you cannot assign this one into result 2. You have to assign to optional of optional, because there is one option inside another one, and how you can extract the value out and get the one by the flat map. Just run this one, and it has given 3 as well. Okay, last 3 of them are giving 3, 3, 3, and 3. All right, so flat map remove the unnecessary layer. So chaining calls to flat map is useful when you want to transform one optional type to another optional type. Okay, next, collecting results. So collecting results mean group the results. One thing you need to remember over here, that these methods are in collectors class. Okay, they are in collectors class, and collector is an interface. So in Java, if class name and interface names are same, then class name end up with s, and interface end up without s. So in collectors class, there is a function averaging double, averaging int, and averaging long. It calculates the average of the 3 core primitive types and return double. Counting counts the number of element and return long. Joining, it creates a string using char sequence as a delimiter between elements if one is specified, and return value when we pass to the collect is string. Okay, so the rest of them we will go one by one. Next, the stream. In the stream class, there is a method called as collect, which takes collector interface as an argument. So you need to remember that in Java, if the class and interface names are same, then the class name ends up with s. So there are many classes, so I have mentioned only 3: collections, collectors, and paths. Corresponding interface names are collection, collector path. Collecting result means group the result. So we collect the result by using basic collector, collecting into maps, collecting using grouping, partitioning, and mapping. Collecting using the basic collector. For that, I would like to mention only 3 methods. So these methods are in collectors class. These averaging, double, int, and long. It calculates the average of our 3 core primitive types and return double. Counting, it counts the number of elements, same thing as count, and it returns long. Joining, it creates a single string value using the char sequence, and it could be a string or string builder. So as you know that both have implemented char sequence interface. It's used as a joining of the elements in between. To explain this, I have created a class collecting collectors. Let's create a stream of string. And the string are lions, tigers, bears, and then use dot collect collector dot joining, and here we can pass string, put him in the variable result, and print the result. So all of them are here. So let's use one more method. As I have shown you, everything now onwards is in the collect method. Okay, so collectors, this is a class, it has all methods, average int, and I'm averaging the length of all strings. So it will add and then divide by the number of elements, which is 3. So 5 plus 6 plus 5, 16 divided by 3, 5.333. You can see that. Okay, let's see. You want an element start with S. So put T over here and then collect. Whenever you use a collector method, you always put inside the collect methods. Okay, collectors dot to, if you want them the result in the set, so there's a set. You can also do in the list as well. How you print? Put them in the variable, result 1, and print the result. Okay, so it has given the tigers, which is in the set. For instance, if there is one more, TOADS, toads, and you want to print in the sorted fashion. So this is not a sort because I is lesser alphabetically than O. So how could you do that? For that, you use to collection, and here you pass a reference of the new object of tree set. How you print? Put them in the variable, name as result 2, and then print. So now it will be in sorted. Tigers come first, then toads. All right. Next, collecting into maps. To create a map, hash map or tree map, we need to specify two functions. So the first function tells the collector how to create the key, and the second function how to create the value. And we're gonna use toMap function. So it has two functions. The first one is for the key, another one is for the value. The third argument in the overloaded function is a merge function. For instance, if the keys are similar, then it uses the merge function. There's also another overloaded method with supplier. I'm gonna use all of these three methods to collecting data into maps. All right. Earlier I have collected data in string, double, set, tree set, and now how I collect into a map. For that, I have created a class collecting maps. I'm gonna use the same stream of strings, lions, tigers, bears, and now you need to collect. As I said, we always use collect method, and inside the collect method we use all those methods of collectors class. So we need to collect them in the maps. So I'm going to say collector dot to map, and in the map there are two functions. First is for the key, another is for the value. So whatsoever you put it in, the same is output. And for the value, I need the length of strings. Okay. How I'm going to print them? Control Alt V and say map and sout map. Okay. So keys are string and values are integer. So lions 5, bears 5, tigers 5. Okay. Key value, key value, key value. What would if you do the reverse key into values, right? So you might be thinking very simple. Just copy this one and let's do like this, and put him in the variable map1 and print. But what would happen? Just run and see, it gives an exception. The duplicate key found 5. So lion's length is 5 and bear's 5. If this thing happen, we can use the another function of toMap, which has binary operator. So binary operator means to input, and what it does, S1 plus S2. All right. So if the key is duplicate, merge function will run. Let's see. So see, both have the same key. It merges both of the values and put here 5 and then here 6. For instance, we would like to see that what is the class we are getting here, because map is an interface, so it is returning some kind of a class, so that's the we are assigning. So it's returning the hash map, which is not sorted. What if we want the sorted map, which is a tree map? So there is another overloaded function, and here we can pass the reference of the new tree map object. Control Alt V. So I'm going to create a variable named map2, print out map2. So the result is same, but if I check the class, it will give the tree map. Okay, tree map. The previous one has given the hash map. So tree map is the sorted one and hash map is not the sorted one. Okay. Just what I would like to mention that you can also write this one like function dot identity. So function dot identity, this method does the same thing. Return a function that always return its input argument. So which is, it is equivalent to this one. So you can use function dot identity as well. Collecting using grouping. Grouping means group all the elements of the stream into a map, and we are using the new method which is called as grouping by. So the first version takes the function, the second version takes a function and the collector. If there is a collector in a method, we call it downstream collector. Downstream collector means a collector inside another collector. So you can call any method of collector again. And the third one has a supplier. So I'm going to explain three of them. It creates a maps grouping by the specified function within an optional map type, supplier, and optional downstream collector. And it returns the map type. Key and value is a list. Okay, let's see that. I have created a class grouping with a main method. So I am going to use the same stream of a string, and then I am going to call the collector methods. So collectors dot grouping by, and the first one is a function. So I said string length. Okay, and put this one into a variable map and print that map. Let's see. So you can see that now instead of merging the string, it has created a list. So the list of elements, those the values have, those the length is equals to 5, and the list of element whose length is 6. Okay, for instance, if I would like to collect everything in the set rather than the list, so by default is a list, so how could I do that? So the second overloaded method, you need to mention a downstream. Downstream means another collector. So collectors have a method to set, right? And now Control Alt B, collect this one in a variable and print the variable, right? Let's see if the result is same, but now you can see that here is a set, so by default is list. Next, for instance, if you want to collect this one in a sorted fashion, so how could you do that? For that, you use a third function. So you need to mention a supplier. So I'm going to use tree map new, which is a reference of a new object of tree map, and I'm going to say this variable map 2. So now you can see that instead of the map it is tree map. Okay, and print this one. So lion, bears, tiger. All right, so what would if you want to get in the list rather than set? So you just need to use toList, Control Alt V, and so now it is a list. Okay, so right, so now you can see that with the tree map it is no more set, it is list, because you change into list. All right, next, partitioning. Partitioning means splitting list into two parts, true and false. So for partitioning, in the collectors class there are two methods, partitioning by, and the first one you put the predicate, another one is predicate with a downstream collector. It creates a map grouping by the specified predicate with the optional further downstream, and it returns the map boolean list of type. Okay, let's see that. I have created a class partitioning with the main method. I'm going to use the same stream, and as you know, we have to call the collect method to use collectors, and in collectors there is a method partitioning. by. In partitioning by, you need to mention a predicate, a condition. The condition, I say, if the length is less than equal to 5, then put the values in the true, and if not, then put in false. So Control Alt V, I'm gonna say this one is map s out map. Let's see how it is. So less than equal to 5, both are here, and the key value is true, other one is false. Okay, what would, if I say less than equal to 7, then so all will be true and nothing will be false. Okay, because you know that we do not have anything bigger than 6. What would, if you want to collect this one in a set, so you use a method with the downstream, and now you can see that it's a map boolean set, rather before it was list. Okay, so now it is in the set. And if you print this one, it gives the same one like as before. Okay, unlike grouping by, we cannot change the type of a map that gets returned. However, there are only 2 keys in the map, so does it really matter which map type we use? Instead of using downstream collector to specify the type, we can use any of the collectors that we have already shown. For example, we can group by the length of animal names to see how many of each length we have. For instance, we can use like this. You have to use collect method, and then inside the collect method you can use the collectors method, grouping, and grouping by first is a function, so you say string length, and then collectors dot a method name is counting. As I explained, the counting counts the number of element. Okay, and then put in a variable map3 and print map3. Okay, so you can see that there are 2 strings have length 5 and 1 string has length 6. Okay, so length is a key and number of them is a value. Okay, pretty nifty. Next is mapping. Mapping means let us go down a level and add another collector. So that's what we do. We use a downstream collector in a mapping. For mapping, we use a mapping method, which we put the function and downstream collector, and we use the mapping for add another level of collectors, and it returns a collector. Okay, I would also like to explain the method max by and min by. It finds the largest smallest element in the stream and return the optional. I have created a class mapping with a main method. I am going to use the same stream, and then, as you know, always a collect method, and then I am going to use collectors dot grouping by. So first is a function. I said the same thing. I need the length of the string, and then what else I need in the grouping by, control P. It says the downstream collector, so this is a collector, collectors dot, and here I can use a mapping. So mapping, what in the mapping, function and another collector. So you can put a function s dot jar at 0 and another collector. So collectors dot min by, which gives a minimum one. Let's put it here. Control P. So it has a comparator, right? So how we pass the comparator? The two values, and then a minus b. If it is a is less than b, then it will give the minus. If a is equal to b, it will give 0. If a is greater than b, it will give positive. Okay, and as you know that I am going to put in a variable called as map, and then I am going to print. So you can see that this stream, collect and collector grouping by, and the length is pretty familiar. So here in the downstream I have used mapping, and in the mapping actually you can use a function. It has given the length and the first character, bears in 5 and tigers in 6. Okay, in the exam you might get in more kind of simple way. Instead of collectors dot grouping by, you can only see the grouping by or only mapping or only min by, and all of these are static import. Just put the star here. All right. So this is a way of using alternatively. So both have same results, but this one is more readable. We have seen all these functions with the exception of these summarizing double int long and summing double int and long. You can use them. It's only for the utility functions, and this is only for the addition. All right. Next is check exception and functional interfaces. So this is also an advanced topic. How do you handle an exception if you are using a reference of a method which throw an exception in the Lambda expression or in the method reference? So this topic is also very important. So there is a class with a main method, and now I'm going to create a method private static list of string name as create, and this method throw an IO exception. I am going to throw a IO exception. Now this is a private method. I'm going to create two public method, public void good and public bad. In the good method, I'm going to call a create, which returns list of string. I can create the stream and then use the count method to count the number of element in the stream. So we need to add here IO exception. All right. So this is a good method. Bad method. For instance, exception case study, and now I'm going to call the create and Control Alt V and just make a variable of supplier S. So what will happen that it says unhandled IO exception. What would if I throws IO exception here but still giving to me? All right, it doesn't compile. So how we gonna use a method which throws an exception in method reference or lambda expression? So there are two approaches. Number one, handle exception in the method, and number two is create a wrapper method. Let's see. So approach number one, I'm going to say public void ugly. Alright, so I'm going to copy this one here, and it's a method reference change into the lambda, and the first way is surrounded with try catch. So I have surrounded this one with a try catch. Let's change a little bit this one to throw new runtime exception. So there's a lot of code and it looks a little bit ugly. Let's do the approach 2, which is recommended one, wrapper method. So for wrapper method, remember that one we made the private method and another one we make the public method. Okay, and public method is calling the private one. So private method handles all exception, static list of string, and say create save, and this one handles all exception, and wrapper method is going to call the private method. Okay, how? The same way. but here it's going to call create save. All right, and now it's not going any kind of exception. All right, so this way is pretty acceptable because we don't need to mention outsiders how we deal with our exception, and we just want them to call the wrapper method which has the reference of our private method. So this is also a real world scenario. I hope you like my video. Wish you best of luck for your exam. Thank you.